project on the Back to Basics series is a stand for my wood lathe. Now this is the original stand I did well over 20 years ago, and there was 90% dowel construction, and at the time I was quite happy. I just threw this thing together, but after 20 years it's still absolutely solid. It's as solid as the day I built it, but I wasn't happy with the design. Now, don't let anybody fool you about the strength of dowels. German tests and my own tests have proved that dowels done properly is the strongest method you can get. And that's been proven by a German test and also our own tests over the years. The main reason people don't like them is they can't do them. Certainly, most people can't even do 2 accurate dowels, never mind 5. So it's the strongest system there is. There's no doubt about that. Now, this is the new design. It's I'm much happier with it. It's got tapered legs at 8 degrees, so that gives it better stability. It's got lots of shelf space, one large one in the bottom and one on the top. This one on the top is mainly to house the motor. The lathe is pulley driven, ancient, but it's still effective. This here is a strength component, a longitudinal rail, but it also forms a lip for the upper shelf. There's storage up here as well, and we've got storage down below here, ample storage down here with another lip to contain the shelf. Also incorporated, I have a smallish workshop, so I need casters to move the stuff around when I'm working on various projects. I have locking casters. If you buy these, be careful you get the right ones. Locking casters, now that raises it at 4 inches or so, which gives you ample room for your feet when you're working on the lathe. As I said, it's very stable, very functional, and far removed and much better than the original, which I threw together and I wasn't really very happy with. A slight departure from the norm with the construction of this stand. We've actually made an order of 1/2-inch guides and dowels, and we decided to experiment here. It's not really required. 3/8 dowels for this is absolutely perfect, but since we've ordered these, I decided to try it, so we'll get into that in a minute. Now, of course, with any join, we begin with the check marks or numbers. I've got just used check marks in this instance, so check mark here, here, there, and there. Same over here. We're going to use a different method for lining up this. But you'll notice here that this is 8 degrees, and I've got to bring it to your attention that Dowelmax automatically adapts to that angle. It will, if it's exactly 8 degrees and you line up Dowelmax with it, it will be exactly 8 degrees to the horizontal. Now, if you were doing a mortise, great joint, but if you were doing a mortise, you could do the mortise in right angles, so that's fairly straightforward. But now when you come to do the tenon, you've got to do it at 8 degrees, or this is slightly more, at 8 or 10 degrees to the horizontal, and that's really, really tricky and very time consuming. But as I say, with Dowelmax, you don't have to worry about that because it does it automatically. Now we'll put this one in the vise. See, this is 1/2 inch and it's way overkill, but it's just an experiment. Now with the 1/2 inch, there's a check mark here, check mark there, check mark here, check mark there. So you line all these up and bring it up, align it to the end here. Now this would, there's a slight difference in the simple calculation for simple formula for centering. We're going to try and center, we are going to center on this stock here. It's half the thickness less 5/8 rather than 3/8 with the other system. So this is 1.5 inch, so half, that's 3/4, minus 5/8 is 1/8 of an inch. So we've installed 1/8 of an inch spacer between the reference bracket and the reference block. That's the one you can see in there. And of course we line up to the check marks and the end here. And then we drill, use a 1/2 inch drill, and we drill through 1, 2, 3 and 4. And you can do this either way. If you're ever doing it, you must make sure that these two are identical. So you have to either put them together and draw a line which is exactly the same on both, or we can use, this is a distance gauge I've just thrown together. It's we don't have the components for the 1/2 inch yet, so I just made this up. To suit. It's not non-adjustable, so it's not that great, but it's okay for this particular one. So we put it in the last bore, make sure it's absolutely level, and bring it up and tighten up, and then drill through 1, 2, 3 and 4 again. And that's all there is to it. It's all within thousandths of an inch, and you can just imagine the strength in this joint. I mean, it's nothing short of incredible. There's nothing on the market that would come even close to this. This is way over the top. In this case, it's way too much, but I just wanted to show the result. As you can see there, this is 7/8. There's, you know, a very small distance between them, but it's very, very strong. I mean, the whole thing has to fail before anything will fail here. The wood would fail before the joint. I'll just show you this one going together. Finished article, absolutely rock solid.